Alright, so for my numerical calculation problem, I went ahead and did very similar problem to the one that we had posted. I just went ahead and changed some numbers around so we could try to play around with Python and see if we can get a value. So in the problem that Dr. Elaine had posted, let's see, we're going to scroll up here. It says a ball has a mass of 0.5 kilograms and released from rest at a distance of 2.4 meters above the floor. How fast is it moving right before it hits the ground? So what I basically went ahead and did was I went in and I changed, instead of 0.5 kilograms, we have a ball with a mass of 0.26 kilograms, and instead of being released at 2.4 meters above the floor, it is going to be released at 5.6 meters above the floor. So with that being said, we use the same diagram. There's only one force working on the object, and of course it's the gravitational force. If we scroll down and we look at our diagram, anytime that we use gravitational force in the y direction, we know that it's going to be constant. So of course our gravitational force is going to be 9.8. We are working with our y plane. Since the ball is being dropped from a certain height and is going down, we're only going to be focusing on our y coordinates. So with that being said, the ball, like I said, I went ahead and changed the numbers, so it was released from 5.6 meters above the floor, with a mass of 0.26, as you see there in step 7, and our starting initial velocity, since it was starting at rest, is 0. So we go ahead and plug that in, and we follow our formula of velocity plus acceleration times distance over time, and we go ahead and print our final velocity. And as you can see, it gives us a diagram, and our final velocity is negative 10.486 meters per second. Our final velocity can be negative. However, when we deal with gravitational force, we don't use negative numbers because we want the energy that is working upon the object to be positive. But that does not mean that we cannot have a negative final velocity. So in step 2, we did a different graph. I still went ahead and plugged in basically everything that I had to plug in. Our gravitational force is constant, so we put that in as 9.8. We're working in our y coordinates, so y is going to be the meters above the floor at 5.6. Our mass of the ball is 0.26. Starting velocity is still 0. Time is 0. Distance divided by time, it's going to be 0.01 as our constant. And then we go down here and we plug in our same formula. The only thing different is that we're going to find the kinetic energy that the object has, and we plug that in with the mass of the ball of 0.26 kilograms times mass times velocity squared, and we still get the same answer. And this is from our starting initial to our final velocity. So therefore, this is all the information that was plugged in. Kind of changed around with some of the numbers a little bit, and I ran the program and was able to get some values. So that's pretty much it. I'm going to work probably on a few more numerical calculations just as a bit of practice, but therefore this is our answer that we get. We get negative 10.486 meters per second for both graph 1 and for graph 2. Thanks.